say, Miss Lovelace?
Miss Lovelace.
I know, what a fun, sad name, isn't it? Sad, Lovelace. Anyway, so I'm going to get to teach your math lesson today. I'm putting the papers on your desk, but please don't touch them yet. We'll use them in a few minutes once we get started. Once we get going on our math lesson today, you will need a partner to work with and talk with. So if you just kind of clear your desk area off, because we'll be using paper, maybe some cubes, but for the most part, just the paper. So you just need to kind of, you can slide it to the side. Just give yourself room to write. It doesn't have to be completely off your desk. Unless you have another desk, then you have a place to store things, don't you? So would you go ahead and, like, I know you're in groups, so you'll be talking to your groups, but you probably, do they have a partner that they talk with typically? You just kind of talk through your whole group?
Yeah.
Perfect, well that works for me. We'll just make sure you're talking within your group. So I will have you working in those groups today, okay? All right, so here's a couple of things I need you to know. Pencils need to be down and listening, and while you're working in your groups, let me tell you some of my expectations, okay? So when you're working in your groups, if our friend Grayson here is talking, you guys are going to be looking at him and listening to him, right? And if Denver, is it Denver? No, yes, Denver's talking, looking and listening, right? And so we want somebody to watch and listen to us if we're talking, so we want to give that same respect to our friends, okay? And I might come around and ask you to look at certain solutions and talk to your neighbors about that. So just be sure that when you're in your groups that you're paying attention when someone's talking and you're engaged in the conversation, okay? All right, are we ready to roll?
Yes.
You ready for some math?
Yes.
It's going to be more fun than recess. What do you think?
Yes.
I think so too. So let's talk about our learning targets for the day, okay? So today you're going to be creating an equation from a number line. Turn and tell the people y'all sitting there, what's an equation? What do I mean, equation? What am I wanting you to create? What's an equation? Okay, so come back to me. Somebody tell me, if I'm asking you to create an equation, I want to be sure everybody knows what that is. So what is an equation? Who can tell me? Yeah.
An equation is like a math problem.
Like a math problem. Would you agree? Can somebody add on to that? Yeah.
It's like 9 times 4 equals 36.
That is an equation. Would y'all agree with that?
Yeah.
That's an example. Are there other equations we could write? Yeah, other operations we could use, but somehow you're going to be writing an equation from a number line. So you're going to be looking at a number line and you're going to be writing that equation. Y'all got it? So tell your neighbor what you're going to be writing today. Okay, I heard some things. Are we writing number lines?
Yes.
Or are we writing equations and creating equations? Equations. So how will you know you've learned it? So today you're going to know you're successful if you can do a couple of things for me, all right?
Yes.
You'll know you're successful when you can write that equation. Remember that we have to do? Everybody's going to be writing some kind of equation. And you're going to have to be able to explain how it represents the number line. That's not what we had on our original one, was it? I don't think, but it's okay. So we're going to explain how it represents the number line. Are you with me? So can you just write the equation and say I'm done?
No.
No. Tell your partner what you're going to have to do with the equation. Tell your partner what you're going to have to be able to do.
What it represents. Show your work.
And then talk about how it represents. Exactly. So what's that other thing we have to do besides write the equation? Yeah. Explain what it represents. I think the other piece, for some reason it didn't save on there, is that we might even label the pieces of our equation. So if we had 2 plus 2 equals 4, then you might tell me what the 2 represents and the other 2 represents and the 4 represents. That was on there, it didn't save on there. So if you're thinking about that, I may ask you to label your numbers in your equation, okay? So we're going to write some equations and we're going to explain how we know what they represent. Are you ready? All right, so your task that you have in front of you looks like this. Today some students were in class, y'all, and they had to give some oral reports. And the teacher, I heard them talking, they were trying to plan that they had to be done with these reports in 15 minutes. That's all they got, 15 minutes. And so every student is going to get 3 minutes. The teacher, she needed to figure out how many kids could go and do their report in this 15 minutes. So do you think we could help her out? So she made this line, and kind of showed, and you see it on your paper there. And so what I need you to do is what it says here. Everybody look at that paper that you have in front of you. If you haven't passed them out, go ahead and pass those out to your group. And let's look. You'll see the same problem in front of you as you see on the board. So today, we're trying to help that teacher out and figure out how many students can go and give this report in 15 minutes. But remember our learning target, we're creating equations to represent this number line. So look at what your instructions say. Everybody put your finger right under the number line. Put your finger right under the number line. You see that word look? It says look at the number line. Does it represent this problem? If so, what does jumps mean? Write an equation to match the line. So it asks you to do what we said our target and our success criteria would be today. You're going to write that equation, and you're going to be able to explain what the equation means and how it represents. Are you ready to roll? So I'm going to be setting my timer, and I'm going to be walking around and talking with you all about what your thoughts are about this number line and your equation. But before you get started, I'm going to give you 60 seconds of private think time. 60 seconds for you to look at this yourself and see if you can come up with an equation on your own before you talk with your partner. So 60 seconds of you just thinking and writing, and then we'll talk. Ready? Go. Private think time is over. That was quick, wasn't it? So now we're going to spend the next 8 or 9 minutes talking with our group about our learning target for today. We're creating the equation to match the number line. We're talking about what does this represent, what do the jumps represent, and then you're going to be able to explain. So I'm coming around asking you some questions, and I want you to talk with your group. Remember how we talk and listen. Go ahead, share your ideas with your group members. What you guys making up here? You wouldn't? So tell me what you know about the problem. What do we know?
It's probably going to be like 15 times 3.
You think it's 15 times 3? Why don't you write that down and see, and we'll talk about it. Why do you think it's 15 times 3? What do you know about multiplication that made you think it was 15 times 3? What did you just say? Say that again. Where does he see 5 jumps, y'all? Do you see it? Go ahead and point to the 5 jumps. Can you kind of circle those on your line? Do you see the 5 jumps? There they are. So that's 5 jumps. So we wrote 15 times 3. Where's the 5 coming in? Oh, he says maybe we should write 15 times 5. Or he says at the end. 5 15s or 15 5s, he says. So let's look at the line. Does the line show us 5 15s? So look at your line. Here's one jump. What does one jump represent? How far did the first jump go? It went to 3. So how big was the first jump? The first jump, 3. And how big was the next jump? 3. How big was the next jump? 3. Uh-oh, we got a bunch of 3s. What equation could you write to show me how much they're jumping on this line?
The answer is 70 times 3.
Okay, why don't you write that down? And then I'm going to bring you some cubes. And I want you guys to work on that because you're telling me that they're jumping multiple jumps. So maybe the cubes will help you model out how many times they're jumping and what the jumps represent. Remember, part of our success criteria today is to explain what the jumps mean and what the equation means. So we want to be sure we're doing that. So go ahead with your equation. I want you guys to work together to figure out if you're jumping How far do we say every time? 3 every time. And how many jumps do we do? 5. So can you model that with these chips? If you have 5 and you're jumping 3. Okay, let's see it on the model. And I'm going to come back to it. Okay? All right, let's talk over here.
I think the answer is 5 times 15.
I want you to see if you can. I'm going to talk to you in just a second, but I want you to think about, is there another equation you could write?
We got 15 divided by 3 equals 5.
Look at this. Why does she, Addie, have 3s above each one of these jumps?
Because they're counting by 3.
They're skip counting by how much? 3. So how many 3s did she jump?
5.
5.
5 times 3.
You're thinking it's 3 times 5, and you said 5 times 3.
Or 15 divided by 5 equals 3.
So which one's right? 3 times 5 or 5 times 3? How? I don't understand.
Yeah, they switched it.
So what does the 5 tell you?
The 5 tells you how many jumps they
Jump. So remember, a part of our success criteria was to write an equation and explain.
Yeah.
So if you're writing that equation and you said it was 5 times 3, so could you go ahead and write that down?
Yeah.
Could you write that down for me somewhere? What did you just tell me the 5 represented?
How many jumps?
Jumps. But let's use the words groups or number of groups. Which one did it represent, or the size of the group? Was it the number of groups or the size of the group?
Number of groups.
So could you label that? Interesting. So I wonder what the 3 represents then. And you guys were telling me that there was some kind of division equation.
Yeah.
How in the world can there be 2 equations for the same problem?
It's a factory.
It is. So I want you to talk about how that can be. How can it be a fact family? What do those numbers represent? Remember our success criteria? We got to be able to label and explain. So as you're writing those other equations, we want to label and be able to tell me why both of those work. Okay? So talk to your group. Come up with a good explanation. All right, you guys are telling me that you wrote a division equation.
Yeah, we
Why?
wrote a whole fact family now.
Oh, you did? So, okay, tell me about your first equation. 15 divided by 3 equals 5. What is, remember what we're doing today? We're creating equations. Y'all have done that. Check and check. But we need to be able to explain how those equations represent the number line. All right, so what do you mean you found it?
Well, we counted all these and get 15, so we knew that was our total. And then right here, it goes 1, 2, 3, 4, 5.
Okay.
And then if you did 15 divided by 5 equals 3.
Okay.
And then you could flip it into multiplication sentence and say 5 times 3.
Okay. But what I'm wondering is, what do those numbers actually mean? What does the 5 and the 3 mean? So look at your number line here and think about the problem. Remember what's happening with the problem? We have 15 minutes and we have 3, we're doing presentations every 3 minutes. So what is the 5 telling us?
It's telling us we're counting by 5 like the same.
Did you hear what she said? We're counting by 5.
Yes, but also how we got the 3 is if you count 1, 2, 3, 4, 5, that's 5. Then 1, 2, 3, 4, 5. 2, 1, 2, 3, 4, 5. That's
Yeah. So let's talk about something Denver just said. She said we're counting by 5s. Can y'all prove that to me on this line?
no, we're not counting by 5. We're counting by 3.
Oh, she says we're counting by 3s. So she's correcting herself. Okay, so if we're counting by 3s, I need you to use this language. Number of groups or size of the group. What's the 3 represent or the 5 represent? What do you think? Go ahead.
I'm asking her.
When we get done with this, you can. So what do y'all think? What does the 5 represent? Number of groups or size of the group? What would make you think it was the number of groups?
Because it's 1, 2, 3, 4, 5.
Good. Could you kind of circle that for me on your paper to show me where? So that is our group. So the 5 is the number of groups. So remember on our success criteria, we're trying to explain. So you might want to label that 5. The 5 is going to be what? Number of groups. So what's the 3 then?
What we're counting by.
So it's the number of groups is 5. How many are in each one? 3. So the size of the group is your 3, is what you're telling me, right? With your models? You agree with that? That would be awesome. I would love that. And so on your, remember, part of our success criteria is not only to be able to write an equation, but to explain what the equation means. So you might want to label some of your parts of your equation down here. So I'm wondering though. So I hear what you're saying. It's 5 groups of 3. How can it be all of these equations? I don't understand how you can write division and multiplication to have the same answer. So I want y'all to talk about how you can explain that to our group when you do that. So what's your explanation on how it can be both? Okay? How's it going over here, guys? So what'd you come up with? He figured it out, he says. What about this model here? You are?
Three.
So he says the 3s, bunches of 3s. Where do you see a bunches of 3s on this number line?
1, 2, 3. So these 1, this is 3, 3, 3, 3.
So you see your 5 groups of 3 in the jumps. Is that what you're telling me? Awesome. So what is that 5 in the problem? So that 5 was, so we got to answer the question here. How many students are going to be able to do the reports that day? What do you think? There's 15 minutes that we have, and everybody's getting 3 minutes.
And the problem is 3 times 5 equals 15, because always in multiplication, the 3 times 5, and the biggest number comes last.
Okay, so we know that 3 was, you said 5 was the number of groups. What's the 3 then?
For how many people can take the test.
So how many minutes they get for each one, right? So the size of the group, right? Y'all agree with that? So if we know it's 3 times 5 equals 15, what I'm wondering is there another equation that would show the same thing that you're telling me right now besides multiplication?
No.
Besides multiplication. He says no. What do y'all think? Talk about it and see if you can come up with it. I will come back to you. Alright guys, let's come over here. Tell me about your models. Oh, we got about a minute and a half left. Remember your success criteria. You have to be able to create that equation and explain what all those numbers mean and connect it to that number line. So can you do that? You got about 90 seconds left. All right, talk to me about what you got. What you came up with.
We think 5 is the number of groups, and 3 is the number of each group, and 15 is the total number of things in all the groups.
Okay, so do y'all agree with what he's saying here? That 5 is the number of groups, 3 is the number in each, and 15 is the total?
Yeah.
So in the line, remember, we're trying to make sense of it, create an equation, which y'all did, for the number line. So you said 5 is the number of groups. So where do you see 5 things in the number line? Where do you see that?
Okay, so I thought the 5 jumps would be 5.
Okay, so the 5 jumps are the number of groups. Did y'all agree with that? So 5 jumps are the number of groups. So what is the 3 then?
3 is the number of minutes.
The number of minutes each person gets, right? So the size of the group. So what's the answer? How many people can go?
5.
You said 15, you said 5. How many people can go in this 15 minutes?
Let's see here. I think I agree with 5.
You agree with 5? Why? You changed your mind? That's okay. You changed your mind.
Total number of minutes.
Oh, gotcha. So in the problem, we were not trying to find the total number of minutes. We knew that. We were trying to find how many students would go, and he said it's 5. Why would he say that? You did make a fact family. But how did you know that 5 people would get to go?
Because 3 times 5 is 15, and there were 3 when the factors.
Oh, I love your language. He said 3 times 5 is 15, and 3 and 5 are one of the factors. But okay, I'm seriously confused then. Because I thought when we're doing math that after the equal sign is the answer. But that's not what y'all just told me. You just told me that this factor is the answer, didn't you? How can that be? Talk to your group about how this could possibly be the answer to the problem when it's part of your equation. Talk to your group.
It's from division. Yeah, so the problem is we should do it division after we did multiplication.
Okay, can I show a picture of that? Will I be able to scroll through pictures, or do I have to take one at a time? Okay. been able to meet our target for the day, which was to create an equation from the number line and then be able to explain what those numbers meant. We're going to take about 15 more seconds while I grab a couple of solutions that I want to show on our board, assuming Miss Lois doesn't break the technology. I'm kind of good at that. And I don't remember where the other ones were. What was yours? Did it just say? I think it did. Yes, it did. And then I want to get yours back here. All right, pencils down, and you guys did an excellent job of talking with your groups and modeling that through. So,
Just click the share button right there.
okay, and then just scroll through. Oh,
You're
thank you. So the first one I did was, and it's probably sideways. It don't make that one. Sorry, on this video. We tried to connect my phone, but it didn't work. Again. Thank you for being patient, guys. I appreciate you.
We'll scroll that way.
Yep. Oh, the little model got cut off though. On that one. Oh, there we go. I'll let you take it. We can. I'll need to get this. And then I'm gonna hit share while you're doing that. Okay, guys, let's come back together. So let's talk about some of these solutions that we're gonna put up here.
I got a mini sharpener of yours.
Oh, much better. Thank you very much. Okay, all right, so let's take a look at this, guys. So remember what we were doing today. Creating an equation from a number line. Do you see some equations? Do you? I do. So I think they were meeting that part of the target for today. And then we were trying to connect them to the number line and what they meant, right, and what those things meant. So let's take a look at this for a second. And I want you to look at this model right here. Right? See this model?
Yeah.
And you see this number line? Yeah. I'm wondering, why do you think this person made this model to help them with this number line? How does this model connect with this? Oh,
Because those are 4 balls.
it is 4. Move one. Can I draw them up here? It had 5 originally, and we moved it. So I'm going to draw them up here. Can I do this? I know how to do this. I just watch me. Are y'all ready for this? Annotate. And so y'all just have to bear with me because I promise you when I first looked at this person's model, there was another row of cubes. So will you trust me on that?
Yeah.
Yeah? Okay, I draw them in pretty, but there you go. So just pretend that that's what you see there. It got moved before I got back with the phone. That's why you need that on your own. Okay, so back to this beautiful model, right? Why would this person make this model to help them with the number line? Turn and talk to the people sitting near you. How does that model connect to the number line? How are they the same? Talk to your group.
It helps me and I'm sorry for moving.
It's okay, sweetie. It's okay. I should have paid attention when I took the picture. It's all right. Okay, so let's come back together and let's see what we think about this solution. How did this model help us with this number line? Somebody share what you and your group talked about. Yeah.
There was 5. If you counted by 5, it would be the same. But the 3, there's 5 jumps of 3. So when the 5 jumps of 3, we got 3, 6, 9, 12, 15. So
Okay, so you're saying there's 5 jumps of 3. Did everybody see that? The 5 jumps of 3. And where was 5 over here?
the rows.
The rows. So we had 5 rows of 3. And those are our groups, right? So our groups, we had 5 of them. And I asked several of you to tell me about the size of the group. So you're saying that we had 5 jumps are 5 groups. So what does the 3 represent? Yeah.
The number in each group.
The number in each group. Would y'all agree with that? So the size of the group or the number of each group. So this was 3, this was 3. In each of our jumps was the group. So when the person that made this model was trying to connect to, okay, well, what do I know about multiplication? I know that it's repeatedly adding these numbers together. So he made the model and then connected it to there. So the groups can be represented in the jumps. Did you know that? Did you know that groups in multiplication can be represented in jumps?
Yeah.
Yeah, well, if you didn't, you know now, right? So in your jumps, the number of jumps are your number of groups. And how far you jump's the size. But, so, he wrote equations here, but I don't, okay, so I see this one, and I see this one. And you guys said it was 3 times 5, right? 5 jumps of 3, but I'm seriously confused. I thought in math there's only ever one answer.
Usually there's 3.
Usually there's 3, you say? So I don't understand why we would write a division equation. Y'all are telling me that the 3 times 5, that the 3 was the size of the group, right? The size of the group, and the 5 was the number of groups. I get that, but what about division? How does that connect to this division equation? Turn and talk to your partner. How does that equation connect to the division equation? How are they the same? Turn and talk. What do you think? How can they be the same? How do they represent the same? Besides fact families. What are the numbers? Remember, part of our success criteria is to explain what those digits mean. So, saying they're fact families.
But it's arranged differently.
They are definitely arranged differently
With the different symbol.
with a different symbol. But what do the numbers mean?
15 is the total.
Okay, so is 15 the total in both equations?
It's the total. It's the biggest number.
So it's the total in both equations? Yes or no? What do you think? What do y'all think?
No.
You don't think so?
Yes.
Okay, so if it's the total in both equations, are the other numbers the same in both equations? Talk to your group. What do you think? Y'all coming up with an answer up here? You got it? All right, well, let's come back together. So I was confused, so y'all are trying to help me out, right? So we knew this was the size of the group, the number of groups, and then I kept hearing this was the total. We didn't really talk about that, but as I was walking around, I heard that was the total. So I was asking some groups. Okay, so this is 15's the total, 3's the size, and 5's the number of groups. So what are they in the division equation? Yeah. So we flip the numbers around, right? But remember, part of our success criteria is to explain what these equations mean and how they connect to the number line. So what is the 15 in the division equation? Is it the size, number of groups, or total? Turn and tell your partner. Is the 15 the size, the number of groups, or total? What do you think?
It always has to do it. It uses the numbers that the arrows land on.
Oh, nice. I like that. All right, so let's come back together. What do you think? What was the 15? Total. So they're the same?
Yeah.
Oh, so it's the 15's always the total?
No.
Is it or not?
It don't always have to be the total in every multiplication and division problem.
Okay, so she's saying no, that the product and our dividend in our division and multiplication don't always have to be the total. What do you think? She's saying, talk to me.
It ain't because, well, in a division, the answer is one of the numbers that makes the multiplication. But if you did like 3 divided by 5 equals 15, that would be a multiplication sentence. Then it's not a division sentence.
Okay, you're right. But she said something very important I want to point out. She said in a division, one of the numbers you multiply together, 3 times 5, is the answer in division. Would y'all agree with that?
Yeah.
Because one of these numbers, the 3 in this equation, does it tell us the size of the group? Or did it turn into something else?
It still tells us the size of the group.
It still tells us the size of the group. So I knew I had 15 minutes and the size of the group was 3. So how many groups could I create? 5. So you're telling me that whether I do a division or multiplication equation, the numbers really tell me the same thing. It's just how I choose to look at it.
Yeah.
I'm following you. So let's look at another solution. And wait, how did she tell me to erase the whole thing? Oh, look at me, I'm getting so proficient with this. Oh, wrong way. I'm at the wrong way. That's right now. Your brain just can only learn something 21 times. Sorry. Thank you for your assistance. So let's take a look at this solution. Now, remember what we just talked about? We were talking about with our success criteria, we were explaining how the equations match the model and how they said the same thing. So look at this, guys. Look at all this. Do you see these? Look what he wrote here. Oh, let's start the pen again. Nope. So he said that 5 is the number of groups, 3 is the number of each. Is that what we already said? Would you agree? So look at this and look how this is a box around it. 3 times 5 equals 15. I want you to turn and talk to your neighbors about why do you think there is a box around this factor in this equation? Turn and talk. Why do you think there's a box around it? The line is the answer. I thought answers come at the end of equations. Why does it do that? What do y'all think? Which one? 5. And 3 and 5 and 15, which is the biggest number? So why did they box 5? Groups, I love it. Can you say that for me? Would you say that for the whole group together? Yeah. All right, so let's come back together. So let's talk about this for a second. We were talking in our group, so I want to hear what y'all said. Why this was boxed. So would you mind talking about what you said? What did you say?
There is 5 groups.
Did y'all hear that?
Yeah.
He said this was 5 groups. Do you remember 5 groups? Where were the 5 groups? Go ahead.
Because there's 5 jumps.
5 jumps, right? There's our 5 groups. Here, 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 and here. We have our 5 groups. Okay, I still don't understand. Why did someone box the 5 though? It is the 5 groups. It's our 5 jumps. Why?
It's the missing number.
What do you mean the missing number?
So like, there's 5 of them, and if 5 is 3 times, say it's 3 times blank equals 15.
3. Oh, let's do
And
a
then you
different
count
color.
how many times there's 3.
So, tell me your name, sweetie. Alex is saying really the equation was 3 times blank equals 15. Can we do that?
Yeah.
Yeah, so really what other equation could we write that helps us with 3 times blank equals 15? Yeah. Go ahead, sweetie. In the back.
15 divided by 3 equals blank.
Right, so we're looking at the same thing. But because we know, y'all told me already in the last solution, that the 3 and the 5 and the 15 represented the same stuff in both of these equations, didn't they? We had the number of groups was 5, and the size of the group was 3, and the total was 15. So it didn't matter which equation I wrote, I'm still going to figure out the answer. So if someone wrote 3 times blank equals 15, that equation would work as well and meet our success criteria. So one more solution. Our timer went off. We got one more to look at. So you're thinking about now what we've discovered so far is that this number line can be represented with multiplication and division because it says the same thing, number of groups and size of the group. So I'm excited about that. Let's see if I can go the right way this time. I did it, did I? Or am I out of solutions?
Turn the fence sideways.
Y'all, I'm sorry that I'm not very good at technology. This way? And then go that way. Okay. Whoops.
Maybe the other way.
Oh,
Did we get that?
fine.
Oh, I think I skipped. This was the one I was going to show next. So, when you're looking at this, the last thing we want to talk about is this solution and this. You see this person, what they did? I think some of y'all have learned about underlining your question, haven't you? Because not once have we really answered the question here. We've talked about what we know about multiplication division equations. You guys have met your success criteria because you were able to take equations and match them to the line. But have we ever said how many students will give reports? Turn and tell your neighbor how many students will give reports. And use the words number of groups and size of the group to help you answer that. How did you know that?
So 5. Must be the number of 5 students. How many students?
It's 5.
Do the thing.
Do the report. Right. So your challenge, what did he say the answer was? 5 what? 5 students. So this time though, was that number of groups or size of the group? Number of groups. So tell your partners what that was represented on the line. What do y'all think? 5 people. How many minutes is each person getting? We're getting 15 total minutes, but each person's getting how many minutes? Look at your line. How many minutes is each person getting? If this is a person, this is a person, this is a person, this is a person, how many would each person get? Look at that. What do you think? Oh, you said 3 maybe? Alright, so let's come back together. So you guys were talking. I asked you to use the words number of group or size of the group in your explanation about how many students will give reports. So go ahead, shout it out. How many students are going to give reports? 5. And so was the number of students the size of the group? Or was the number of students the number of groups?
The number of groups.
Right. So every student or every group is representing one student, right? One student's getting this, one student's getting that, right? So I just have one more challenge question for y'all because you guys have met our learning target for the day. You have created an equation that is connected to the number line. You have labeled it and explained. I'm going to leave you with the last 60 seconds to challenge you to think about something you might explore tomorrow. And it's at the bottom of this. Look at the bottom of your sheet. It says, what if they had 5 minutes for each report instead of 3? How would that change your line? And how would that change your equation? Just take about 60 seconds to keep that thought with your group right quick.
It would just
What did
If you show that in the number line, what would that look like? Did y'all see what he said? So he said that he would go 5, 10, 15, and if they only had 5 minutes, how many people would go? So would your equation be different? Talk to your group. Yeah. What do y'all think? It wouldn't change the model, or it wouldn't change the answer?
It wouldn't change the answer.
So the answer would still be that 5 people could go. And so then if that's true, what are you saying would change? Anything?
The number line will because the 5. This is 5. We're counting my 3s and it's 5 seconds.
No, it's Christmas. Has changed.
So instead of counting by 3s, you count by 5s. So how many people could go? Oh, interesting. All right, come back together. Let's take a quick vote to wrap up our lesson for the day. How many people think that the number line would have to change if I gave every person 5 minutes? Let's vote. What do you think? Some people think it'll have to change. How many people think it wouldn't change? A couple people. So who wants to argue for the last 30 seconds? But you know what math is? It's a good fight. It's a good argument. So let's hear some. Why? Who thinks it would change and why? What do you think?
I think the number line would change because it could be side 5s. They could count the 5s, but it'll still be the same answer.
So she's saying they would count by 5s because we still have only 15 minutes. But this time the size of the group is instead of 3, the size of the group is how much?
5s.
So she's saying if we counted by 5s, do you see that? How many people could go?
3.
Uh-oh. She may have convinced some of us. What do you think, Denver?
You can count 5 3 times.
Yeah. So how many people could go in 15 minutes if I gave them 5 minutes each?
3.
Only 3, right? But did our equation change?
No.
It didn't? Not at all. It flip-flopped, right? We instead of had 3 groups of 5, we had 5, or instead of 5 groups of 3, we had 3 groups of 5. You guys have done a fabulous job with your exploration today. I can't wait to see what else you come up with as you explore some more relationship between multiplication and division. And I have an exit ticket for you. Totally forgot about that. So this is one, we've been exploring these number lines. I want you to just give it a try. It's one problem, that's it. So put your name on it and solve this problem. And you can, it's one